In this example, we're asked to calculate the molar mass of an unknown monoprotic acid. So reminder that molar mass just means grams per mole. So in this example, we're given the grams of our unknown acid, and so we need to determine the moles of the unknown acid in order to calculate its molar mass. So we have 0.328 grams of our unknown monoprotic acid, and it's dissolved in water and titrated with a standardized 0.1261 molar sodium hydroxide. And so if 28.10 mils of that basic solution is required to reach the equivalence point, what would the molar mass of the acid be? And so one important thing here is that our unknown acid is monoprotic, which means that when it reacts with sodium hydroxide, it's going to do so in a 1-to-1 mole ratio. Okay, the actual identity of the acid is not important here, just that it's monoprotic, so that I know that mole ratio is 1-to-1. Okay, so I'm going to calculate the number of millimoles of my standardized solution sodium hydroxide because I have its volume and its concentration. Okay, so I'm going to do 28.10 mils times 0.1261 millimoles per milliliter. That works out to being 3.543 millimoles. Okay, my millimoles of my unknown acid is going to be equivalent to the millimoles of sodium hydroxide because they're reacting in a 1-to-1 mole ratio. And so my millimoles of HA is going to also be 3.543 millimoles. And because I want a molar mass that's grams per mole, I'm actually going to need to convert my millimoles to moles. So I'm just going to take this and I'm going to divide it by 1,000. There's 1,000 millimoles in 1 mole. So that's 0.003543 moles. And so the molar mass now of HA is just going to be its mass in grams, 0.328 grams, divided by the number of moles. And so that works out to being about 92.6 grams per mole. I'm not going to do the next problem. I'll let you go ahead and try that one on your own, and please refer to the completed copy of the notes posted online.